I'd like to talk a little bit about the board alignment feature here in Cleanflight. I think there's some confusion about how that's used, when it should be used, and when it doesn't need to be used. Maybe I can help clear some of that up. The board alignment feature is used to cause the frame of reference that the flight controller uses internally to align itself with some external frame of reference, such as the frame of our copter. The most common way that board alignment is used is to adjust the yaw on the flight controller. If you've got the flight controller with the USB port sticking out the back, it's common to install it sticking to the left or to the right. And if we didn't adjust the flight controller's board alignment, then the flight controller would believe that pitch was facing this way. And when you pitch forward, the flight controller would actually cause the copter to roll to the left. Okay, so by inputting 90 degrees of yaw adjustment, we can cause the copter to pitch and roll as we expect it to. But what about more complicated examples? Here we're looking at a picture of the Green Gorilla frame, and the Green Gorilla frame has the motors installed at a 35-degree angle relative to the frame. And that means that when your flight controller is installed, wherever it's installed, the flight controller is going to be misaligned with those motors. And that's the time when I believe that the right thing to do is to use the board alignment feature. Now let me tell you why it's a bad thing to have the flight controller misaligned with the motors. The flight controller is always going to try to pitch and roll around its own internal frame of reference, whatever that might be. So it's when you input roll, the flight controller is going to try to make itself roll to the left or to the right, and pitch and yaw and so forth. If you have a scenario, let's say we've got a scenario like the Green Gorilla frame, where the motors are tilted forward. And let's imagine that the flight control board is, you're going to have to just imagine it. Imagine that the flight control board is flat instead of being like this. So when you input roll, if you don't have any board alignment, when you input roll, the flight control board is going to attempt to roll itself. You follow? And if you look at what the motors are doing, what the copter is actually doing, we are not getting pure roll along the plane, around the plane of the motors. So what we're actually getting, let me tip it away from myself, it'll be easier for the camera to see. As I roll, can you see that the copter is yawing as well as rolling? If not, play with it yourself. It's a little hard to maybe visualize. I'm going to roll a pure roll around the flight controller. Let's imagine my hand is the flight controller. So it is a pure roll around that axis. It is just spinning perfectly. But because, and of course if the copter was aligned with that, it would also roll. But because the copter is tilted, the plane of the motors is tilted, when we get a pure roll around the flight controller, we actually get yaw in addition to roll relative to the plane of the motors. And here's why that matters. Your copter has much less yaw authority than it does roll authority. If you think about it, when your copter does a pure roll move, two of the motors spin down, two of the motors spin up, and it spins to the side. It's a very simple move. When your copter has to yaw, two of the motors spin up diagonally, and two of the motors spin down, and it yaws. But because we're relying on counter torque and we're not actually thrusting in that direction to create the yaw, the thrust of the motor is going down. We're actually relying on counter torque from the spinning props. The yaw authority is much weaker. Not only that, but if you think about the roll move, these two motors spin down and these two motors spin up, right? And for the yaw move, these two motors spin down and these two motors spin up. Well, one of these motors is going to have conflicting commands. It's going to need to spin up for the roll, but down for the yaw. And there's going to come a point where those two things come into conflict and they can't both be satisfied. And that's when you sort of run out of control authority. And what happens then? Well, the copter will lose its alignment. It'll lose it'll sort of flip out. Maybe the back end will spin out. Maybe it'll stop being aligned on whatever axis it is that you're trying to do your move, and bad things will happen. So my philosophy is that we always want to have the flight controller's internal reference frame aligned with the plane of the motors. And what that will do is that will cause your pitch and your roll moves to be pure pitch and roll moves with no additional yaw coupled into them, which will maximize your pitch and your roll authority. And maximize your overall authority. It keeps the yaw, which is the weakest link, from limiting the pitch and the roll, which are much stronger. So how can you check that this is properly done? Here's how. So the first thing you want to do is you want to set your copter flat on the table and confirm that the 3D model is also flat. And if it's not, you go ahead and calibrate your accelerometer just to get the 3D model to sit flat. And then what you're going to want to do is you're going to want to go to your configuration tab, and you're going to want to tweak your board alignment so that the 3D model appears aligned correctly with whatever plane of reference or frame of reference you're concerned with. So if we imagine that I had the green gorilla frame where the motors were tipped like this, what we would want is when the copter is sitting flat on the table, we would want to see the 3D model tipped to match the motors. Okay, so I'm going to set the copter flat, and I'm going to go to configuration, and I'm going to put in, and it's sometimes hard to know whether you should put a negative or a positive number, so just use trial and error. I'm going to put a negative 35 degrees of roll adjustment. Now, you might be confused there for a minute because we're trying to cause the flight controller's frame of reference to pitch forward to match the motors, right? Why am I putting roll adjustment in? Well, remember that I've got my flight controller rotated 90 degrees to the left to make the USB port come out the side. And so the pitch axis is actually facing to the left. And if I want to pitch the flight controller forward from the perspective of the frame, it's actually a roll move from the perspective of the flight controller. The flight controller always remembers its own pitch axis as being the same, regardless of how you change these things. So in fact, I'm going to put in 35 degrees of roll adjustment. I'm going to save and reboot. And I'm going to go back to the setup tab. And now I can see that with the copter sitting flat, the 3D model is tilted backwards. Now, if we go back to this photo of the green gorilla frame, we can see that that's not right. With the copter sitting flat, we want the motors tilted 35 degrees forwards. Okay, so I'm going to go back to my configurator, and I'm just going to, I got the sign of the number wrong. I'm just going to change that to 35 degrees. And now, yes, see, so with the copter sitting flat, the motors, the 3D model is pitched 35 degrees forward to match the imaginary plane of the motors on the green gorilla frame I don't have. Okay, and that's what we want. Now our pitch and our roll moves will be pure and will not have any yaw coupled into them, and that's a good thing because it will maximize our control authority. Let me give you another example of something I once tried. I once tried to set the alignment of the flight controller so that it was aligned with the plane of my camera. Now, why would I try to do that? The reason is that with the flight controller aligned with the frame, with the plane of the frame, it means that when you do roll moves, the camera actually circumscribes an arc and basically makes the shape of a cone, right? So you can see here that if I roll, let me see if I can do it like this. If I do a pure roll move relative to the frame, the camera, we're not rotating around the axis of the camera. What I wanted was a rotation like this around the axis of the camera. It's a little hard to do, I apologize. So that when I rotated, if I was focused on something at the center of the camera, when I did a roll, that thing stayed centered instead of moving off center. I thought that would make my videos look better. And what I did was, again, I'll just give you the example. So here, I think we're going to want minus 20 degrees. Save and reboot. And go to setup. And now with the copter, hang on, with the copter sitting flat on the table, the 3D model is pitched back 20 degrees, which is exactly coincident with the camera. So I've accomplished what I wanted to accomplish, but in fact my flight performance suffered because now the internal reference of the flight controller was no longer aligned with the plane of the motors, and it was much worse. So don't do that. But it's just another example of how you could apply this if you wanted to, just to check that you've done it the way you wanted to do it. Okay, so that's my opinion on board alignment. You should use board alignment whenever your flight controller is not aligned parallel to the plane of your motors. Okay? Uh, and the reason for that is that when your flight controller's board alignment is parallel to the plane of the motors, then pitch and roll moves are pure and do not incorporate any additional yaw coupling, which maximizes your control authority. There's one final question that people might ask, and that is, what if I have tilted motor mounts? If you have tilted motor mounts, the plane of the motors hasn't changed, but the motors are oriented differently relative to the plane. And I don't know the answer to that. I don't fly with tilted motor mounts, and it's kind of a complicated situation, and so I'm going to duck that question. But if you have tilted motor mounts, try it both ways. Try using board alignment to tilt the board 10 degrees or whatever your motor mounts are, 10 degrees, 15 degrees, and try flying it without that and see what happens and see what you like best and comment on the video and you tell me. All right, that's it. Happy flying as always. Bye-bye.